And factors, the determining porosity, there are several factors: grain size distribution, the packing or the sorting of the grains, grain shape, cementation, compaction, chemical dissolution that will result in secondary porosity, and fracturing. This table is another tabulation of typical porosity ranges for each lithology. For unconsolidated sands, reservoir sandstone, compact sandstone, down to conglomerate rock. These are just typical values, so you don't need to memorize them, okay? But in case you need them, in case you don't have an actual number, you can go to these typical values so that you can use them in your calculation or estimation. Porosity in classification. So we can classify porosity into several classes. For clastic rock, first clastic rock, we have very high porosity if the porosity is equals or more than 30%. Then we will have high porosity between 25 and 30, moderate porosity between 15 and 25, low porosity between 10 and 15, extremely low porosity between 5 to 10%, and ultra low porosity in shale reservoir, for example, lower than 5%. In carbonate rock, we have other classification, okay? High porosity if the porosity is equal or more than 20%, moderate porosity, low porosity, extremely low porosity. You can refer to this table. And porosity model for shaly sand reservoir. So let's say this block is a unit bulk volume in shaly sand reservoir. So you have sandstone reservoir, but in this sandstone reservoir, you find shales, and we call that rock shaly sand reservoir. Okay, and of course, if we have this rock, okay, this rock will have volume, but if we break down the volume, this will be like this. First, we have the grain made of quartz, the main mineral, the dominant mineral for sandstone. And then we have mica, feldspar, organics. Quartz and mica, feldspar, organics are sand minerals. And then we have dry clay, which is made of clay minerals. And then at the clay, on the clay, there will always be clay bond water. So water will cover the clay surfaces, okay? So we call it clay bond water. Water will attach on the clay, okay? Attach or absorb, or yeah, water will cover the surface of the clay. And of course, mica, dry clay, and water on the clay bond water, they have volumes, okay? And we call it, if we sum all the volumes, we call it shell volume, okay? And we have clay bond water plus non-clay water, so it's free water, and plus the oil and gas or the hydrocarbon, okay? If we sum all these spaces, these volumes, we call it total porosity. So within the pores, you will find hydrocarbon, oil or gas, you will find free water, and you will find clay bond water. Okay, total porosity. But clay bond water will be in the ineffective porosity. Okay, but for the effective porosity, it will include the free water and the hydrocarbon for the effective porosity. So it's just actually a model, okay, but it is a helpful model. So you can distinguish between the volumes of quartz, mica, dry clay, clay-borne water, free water, and oil and gas.